we talk in video number 2 about the gravity and how where the gravity come from and how the gravity happened, and explain the gravity happened from the rotation of the solar disk. Like the gravity is the force is the rotation force, but act in another way. So right here, like you see, this is the solar disk, and this is the effect of the rotation. Right here, this is the dust. Right here, the small particles and the gas. I try to go to inside the center, and after that, I go another draw. Right here, this is the draw. This drawing, like right here the sun formed, and right here called planet count of cycles is 9166, and I need to explain where the 9166 come from and how this happens. So we have two radios. The first radio for the whole solar disk includes the dust and everything, and the second radius is the sun radius, and we divide the whole solar disk radius by the sun radius. This brings this number 9166. So this means the whole solar disk elements and the gas shrank in a huge sphere, or this sphere is the sun, and this was action. So every action has reaction, and the reaction in this case, the big size of elements like a big rock or small moon can't go inside this one, so the reaction like happen. Another force come, try to hit the big rocks away to go the drive around right here around the center, so making circle like that, go orbiting. And I go more details right now for that, calculating everything and proving everything. And this new discovery is not something like just a theory, but this is a discovery. 1 second, I bring the formula. Is right here. So we say, for example, Earth's approximate distance to the sun. We say circumference of the average solar disk divided by circumference of the sun times Earth's plus moon diameters. It brings the distance from the Earth to the sun. You can prove, you can try this one, and this is proof for this equation. So when you divide how much the solar disk average radius, this is like I said about right here. It's go from average AU to 55 AU. So we add 30 AU plus 55 AU and we divide by 2. This is the average. It is a number like is 6, like you see the number 6,037.5 million kilometers. This is the average for the solar disk in the beginning radius. So when you divide this one right here to the divided by the sun radius, it show up the 9166 cycle. This is average. Like this, we have another step. It's just this squeezing and shrink the solar disk in a small sphere. Was absorbing the small element and the gas and dust, but the big element is to try push it away by this cycle 9166. So when you multiply the 9166 with any diameter, this give you the average distance from the center sun center to the planet center. This go with Mercury, Venus, Earth, and Mars. When you multiply, it give you average distance. So you can try this one and see. We have more equation with more detail and give us the exact number. This is not exact number, but this is average or average. But when we add something, when we add the density and the spinning, it's give us the exact number. So if what if we need like to check the Venus, we multiply Venus diameter with the 9166 cycle, give us the distance from Venus to the center of the sun. What about Mars? We have another formula for Mars too. So this is the second, this is the first formula, and the third video number 3 for to explain what happened. The next equation is more important than the one. This is just to give you more understanding, but the other video is more detailed and give you exactly the same numbers. Thank you.